Alright, here we are. We've got the telescope set up outside, and we're looking at SharpCap, which is watching the live frames coming from the camera. So I've got 8-inch f4 Newtonian with a ASI294, and it's all running into SharpCap. So I'll be taking really short exposures and live stacking them on the fly tonight. Sort of using the camera kind of like an electronic eyepiece. So right now it's looking at Vega and Lyra, and I have a planetarium program here. It's kind of wild looking right now, but this is all the way zoomed out, showing the entire sky looking straight up. The brown perimeter is my horizon, so I've got trees and houses all around, so I've got a pretty narrow window looking straight up, maybe 45-degree horizons. And the large red rectangle represents my finder scope. So I've got a tiny little camera with a tiny little lens, and I accidentally just closed it. Awesome. For whatever reason, that program has teeny tiny window buttons up at the top. But it's a little RisingCam 290 mono camera. And it's connected to a little 4mm wide angle lens, so it gives me a very wide field of view. If you look, you can actually see we're looking at Vega and Lyra. You can see the whole constellation Lyra. There's a little parallelogram. There's Epsilon Lyra. And then you can even see Cygnus. So there's Deneb, and then sort of the cross. And you can even see a little bit of the Milky Way running right down the middle. And not too far off to the side is a tree. As I said, I'm sort of surrounded by trees. If we go back to the planetarium, the red circle is basically where the computer program is pointing. That's kind of the center of view. The white rectangle actually represents the telescope. So you can see that white rectangle actually shows me intersecting with the tree, which is a good sign, which means I made my horizon map fairly accurately. So right now we're pointing at Lyra, and the very close, very nice looking object is the Ring Nebula, M57. So we can select it and then issue a go-to command to the telescope. And now the motors will drive right over there. And the Ring Nebula is really easy to find if visually. If you find Lyra and you look at the parallelogram, the two stars at the far end of the parallelogram, if you just go right in the middle of the two, you'll probably land right on the Ring Nebula, or it'll at least be in the field of view. So if we go to SharpCap, and so on the right side there's a bunch of camera controls. It looks way more complicated than it really is. Basically the only slider I use is this one here, is the exposure length. If I click on the right side, it'll increment by a factor of 2, so this will be 4 second, 8 second, or I could decrease it, go down to 4 second or 2 second. But I'll go up to 8 seconds, and you can see there's sort of a little faint ghostly ring right there, which is exactly what we're looking for, which is nice. So this is just the raw 8-second exposure straight from the camera, no stretching, no stacking. And even with this, you can definitely clearly see some color. There's a red ring on the outside, probably hydrogen alpha, and then there's kind of a pale green blue on the inside, which is oxygen 3. You also see some red and green and blue stars, but they're not really stars, they're hot pixels from my camera. And with SharpCap you can actually apply dark frames on the fly. So as I was setting up, well actually with this color camera you can take all the darks well in advance, but essentially you just cap the camera and you take exposures at the gain and exposure length and the temperature that you plan to image at, and that essentially captures a picture that only contains the hot pixels and some amp glow. And it's a really handy thing because if you just subtract that from the picture you're looking at, so we'll pick the dark frame, we'll select it, and if we subtract that dark frame, which includes all the hot pixels, it should subtract the hot pixels. So now the view looks a lot nicer. And you can also apply flat frames, which is nice. So if the telescope has really heavy vignetting, so if the corners of the field of view don't get as much light as the center, you essentially put like an artist's tracing tablet on the front of it, which is a very evenly illuminated panel, and you take a picture of a known even illumination, and that picture will only contain variance and brightness from the telescope, and you use that as another calibration frame. Basically, you divide your picture by that, and it sort of normalizes everything to equal brightness, which is handy. If I turn mine off, I might be able to see a little bit of dark corners, but my scope is fairly well illuminated, so it's barely perceptible. There, it got maybe a little bit darker in the corners. I'll turn it back on. So the ring nebula is not quite centered, so we can, with SharpCap, you also have crosshairs, which is nice. And to make it easy to sort of aim it, because if I shift it, it's going to take 8 seconds before we even see anything, and it's going to be a big motion blur. So I like to bring the exposure time down. I think even 2 seconds would work. And down here, there's a little histogram, and you can apply a stretch to it. So if you hit auto stretch, it'll kind of boost it. And even in this tiny 2-second exposure, we can still see the ring. But because it's 2 seconds, it's much closer to real time, which makes adjusting the telescope a lot easier. So this little control panel is connected to the mount, and it's always kind of a guessing game on which direction to go. It seems the right way. That'll be good for up-down direction. Now we'll see if west is the right way. Looks good. I don't usually use the crosshairs. I kind of eyeball it. But now we're on target. I usually increase to 8 seconds. I could do 16 seconds, but beyond 16 seconds and my mount can't really track. And the beauty of live stacking is instead of having to have an extremely capable mount, you can just let the software do the long-term alignment. So we're at 8 seconds, and I think we still have the correct dark frames applied. And now we'll go up here. Actually, we'll name it. We'll go M57. This text gets appended to the file name just so it's easier to keep track of what you're looking at. So we'll start a live stack. I previously was stacking, so we'll clear out the old one. And again, there's another histogram down here, and this one's a little more powerful than that one because it also includes some color balancing. But the histogram is a very powerful tool, so if I reset it, this should be displaying very close to sort of the raw data straight from the camera. And looking at the histogram, the far right or the far left represents black, no photons detected, 0 value. The far right is white, completely overblown, fully saturated. The pixels can't count any more electrons, it just ignores anymore. So the neat thing with SharpCap, or histograms in general, similar to the curves tool in Photoshop, is you can remap the camera sensor data. You can remap how it's displayed. So you can say, I want these values to be the new black, and you could go crazy and reassign the new black way over here, and that'll clip almost everything that you've collected. But usually that's useful for just kind of sneaking up and clipping the sky color, sort of the glow. And you can do a similar thing with the gray point. So typically gray is halfway between black and white. But with astronomy, a lot of the stuff we're looking at is pretty dim, essentially dark gray. And it'd be really nice if we could take that dark gray and turn it to at least a light gray, so we can reassign the midpoint and bring it closer to those dark gray tones. And you can see this is looking pretty heinous right now. It's because I don't have color balance. But there's a automatic color balance tool which will do a best guess. Usually it gets you close. I like to sort of poke and prod at these until it looks better. And right now this is a pretty aggressive stretch. It's way more than I would normally do. You can see all the colors sort of lost. It's kind of overblown. So it's all by preference and by feel and by taste. But if we look, we can see maybe just starting to see a faint background galaxy behind the ring. So if we crank that gray point back, the ring's going to look pretty nasty, but we might be able to start to accentuate that galaxy right there. So you can definitely tell there's something there. It's not pretty, but you can detect it. And if we go to the planetarium, we can verify. So this little, I've customized the user interface a little bit so it won't be the same for everyone. But if we look, this is the planetarium's representation of the ring, and then there's the that little background galaxy behind it. Looks like it's ASI294. Since I know the telescope's pointing fairly accurately at the ring, I'm also going to sync the mount just to hopefully improve further go-tos. That was a mistake. I didn't mean to go to. I hit the wrong button. Oh well. We'll see how the live stack handles that. So while it was stacking, the mount issued a go-to. So we'll probably see, might see, yeah, you see some weirdness there. Actually, this will be interesting. So if I zoom out, you can see I started the live stack. There comes a satellite. I started the live stack in one position, and now I've accidentally shifted the mount while it was live stacking. And the stacking algorithm's robust enough that it's just carrying on, continuing doing what it was doing. So eventually, if I stretch this a little differently, you'll see that you'll get this dark border, and it'll continue to get darker and darker because we're no longer collecting information from that area, because now the mount has shifted. It's looking over here. But if we're only interested in the ring nebula, it's not too big of a deal. So you could see how with live stacking you could actually have a pretty sort of low cost mount. It doesn't even have to track that well over long periods of time. You know, the live stacking will take care of those large motions over time. As long as it can track good enough to get, you know, a really short exposure, 2 seconds, 4 seconds, 8 seconds. As long as you can track good enough for that, then live stacking can really help. But I'm going to recenter on the ring just to center up the mount. I think I made a mistake when I did my alignment. So we'll turn the crosshairs on, go back 2 seconds. Maybe we could even go to 1 second. And we'll bring up the hand pad. And I think that was west and north. There we go. That's good enough. Probably overshot a bit. Better than it was. But now I want to sync. And that'll just sync the computer model of the mount to reality so that the computer thinks it's pointing where it actually is. So now let's see, we could check out the double-double. We'll probably only split the first sort of division. I don't think the camera and the telescope have the right sampling to split the components, but we can give it a shot for kicks. we'll turn that off. We're at 1 second, and that's a little much. You can see we're definitely blown out here. So let's see how well it'll handle going shorter. I don't see any hint of elongation. Maybe now. Very, very slightly elongated. You know, this one's kind of elongated in this direction. That one's elongated in that direction, which I believe matches the double-double. I forget which one's which, but the orientation of the two pairs is almost perpendicular. So I can't split them, but we can at least see some elongation. I read in the chat. Hey Tom, Mark, and Benu. This is the double-double in Lyra. So if we zoom out, actually we've got the finder, the wide scope. So there's Vega, and then there's a parallelogram in Lyra, and then kind of off over here there's a star. And if you look at it with binoculars or a small scope, you'll see that it's a double star. And if you look at it with a medium or larger scope, each one of those individual stars in the double is again a double. So there's 4 stars there, which is pretty cool. But my camera can't resolve it in its current configuration. If I put a Barlow on there, I might be able to get it. But that would slow the scope down enough that it'd be challenging to do the deep sky objects, or at least to do it with live stacking and keeping the exposures short. So if I were to put a 2x Barlow on here, it would take my f4 scope and make it equivalently f8, but that would require 4 times longer exposures, which wouldn't be as responsive and fun, for me at least. So let's see what's around. I'm not sure if we'll be able to catch this. Let me quickly change into Alt-Az mode. For whatever reason, the user programmed horizon only shows up in Alt-Az mode. So it looks like we'll be able to catch M13. So let's issue a go-to. Now I didn't do any alignment stars down there, so I'm not sure how accurate this will land, but we'll see. Good enough. So we're at 2-second exposures. I think if I go to 8, we'll probably start to blow out the stars, and we'll lose some of the nice color information. Yeah, it looks like it. So I'll stick to 4 seconds. And because I'm using a different exposure length, I'll want to use the correct dark frame. So maybe a month ago, I sat down and took dark frames for 1 second, 2 second, 4 second, 8 second, and 16-second exposures using this gain, which I just sort of experimentally determined I think I like this gain for this camera, and for my quick, fast exposures. For doing longer exposures, you could use a smaller gain, and that would give you more dynamic range. So at a lower gain, an 8-second exposure might not overblow the stars, which would be nice. But at a longer exposure, you might need auto guiding, and it'd be a little more complex. So we're at 4 seconds. We're on M13, and let's start live stacking. So when I hit this live stack, it's going to take us back to the image that's in memory, which is the ring, but we can clear that. So I'll bring the black point close to the peak. And this is another thing of preference. Some people like to clip more of the sky so that the sky is kind of uniformly black. And I like to have a little bit of the sky glow. And the globulars are kind of fun to play with. You can, with a gray point, you can really kind of accentuate the faintest members way out there, but you kind of start to lose the core. Or you could go the other way and sort of focus on only the very brightest members. So it's a nice way to kind of be able to study an object with the camera. And you can also sort of artificially inflate the colors. So I've just cranked the saturation to maximum. And you can use that to really tell the difference between the colors of stars. So you've got the blue stragglers and then the older, yellower stars of the cluster. Mark's asking for M33. We'll see if it's up. I've got pretty bad horizons, so it might not be up yet. Let me just make sure the clock is synced.
Speaking of the horizons, you mentioned that you made
One second, I gotta mess with Discord's audio settings. It's coming through the speakers instead of the headphones. Can you say something? Just a test. I can't hear it. But for the horizon map, I used the compass and a protractor. So what I did is I took my protractor and I just drilled a tiny hole right in the center position. And I took a piece of copper wire, bent a hook on one side, and ran that through the hole. And I made sure it was fairly straight so that gravity would just dangle it down, kind of like a plumb bob. And then I could sight along the flat of the protractor. And with my finger, I could carefully pinch the wire so that it wouldn't swing anymore. And then I could read the altitude reading. So for the azimuth, I just used the compass. It was I'm not sure the terminology for it, but it was sort of like a military style compass where it's very rectangular and it folds open, and there's a sight glass on the far side, and then there's a magnifying lens that reads the azimuth. So using that, I could pretty accurately sight sort of landmarks on my horizon, you know, the tip of a pine tree or the intersection of my roof and a tree, and kind of go around. And so the readings were not perfect or direct. I put them into Excel, and because of the way the protractor measurement came out, you had to subtract the measurement from 90 degrees. And then for the compass, I had to subtract 14 degrees to counteract a magnetic declination, because the difference between magnetic north and true north. I can't hear you. I think Discord's settings are being goofy. I'm gonna exit and rejoin. So that was my desktop of the computer that I'm sitting at, and I'm remote desktoped into the little mini PC that's sitting outside. So there we go. All right, hopefully that'll do it. We'll see. I've still got the color way boosted. So that's looking pretty nice. So you can go down here and save a snapshot. And you could also save different FITS files. You could save a 16-bit, or you can actually save the raw 32-bit file that's going on in the background here. As it's building the live stack, it's building it into a 32-bit working file. But I usually just save it as a PNG or a JPEG. I don't tend to go back and modify the pictures too much. Still, my audio is still not working for Discord. Let's check out M56, which is pretty close to Lyra. So it looks like a much smaller globular. We could probably go up to 8 seconds. So since we're changing exposure length, we'll also change the dark frame to match. And now I can start to live stack this one. So this is the M13 from memory. We already saved a snapshot of that, so we can clear it out. But it'll be a good direct comparison from one to the other. Just having some issues with the Discord audio. Try one last thing. headphones always get tangled in the Alright, I think that did it. Yeah, I can actually hear. I couldn't hear since I first messed with it. For whatever reason, Discord wasn't using... I'm using headphones through the front audio panel, but for whatever reason, Discord wasn't having it. So I'm using a digital DAC and it's working. Originally, it was coming through the speakers, which was a little loud. Might have echoed a little bit. But recently, I started using a UV-IR filter, which has been kind of fun. I find it really helped with the star colors. No more weird purple and green stars hiding out. Although I do lose a little bit of sensitivity on distant galaxies. But it passes hydrogen alpha, which is nice. Yeah. It was a really cheap SV Bony UV-IR, but it seems to work well enough. And I won't be heartbroken if it gets damaged some night. So if anyone is asking which planetarium I'm using Carte du Ciel, or Cartes du Ciel. I'm terrible with French pronunciation, but it's a free open source planetarium, which is nice. It's a little clunky compared to Stellarium. It's not as kind of polished and nice looking, but it's extremely functional and very adjustable. You can kind of set it up however you like it. And you can even customize all the buttons. You can, disable all of these toolbars or add more of them if you want. But I've got, frequently used settings all laid out so I can use them and all the different field of views. And it has some shortcuts and hotkeys for jumping to different fields of view, which is kind of handy. Yeah. It's almost practical enough to be German. Yeah. And you can also use it to make paper charts, which is kind of nice, because you can go in and configure exactly how everything's viewed, to the T. You can set it up to do whatever you want. So let's check out the Dumbbell Nebula. So we're not too far, and we can check on the wide field. We should be moving. And you can see, I think it's Sagitта. Yeah, the little arrow. So in the wide field, let me close this extra window. That doesn't need to be there. Right, so we can exit the live stack. I'm going to type in M27. So this is another planetary. Like we were looking at the ring earlier. And these are the 8-second exposures. We can start live stacking. We'll clear out the old globular cluster, although we never saved it, but it'll still be there tomorrow. So this is just the first single exposure. Usually it ends up looking a little noisy, but as more and more exposures come in, the noise kind of settles down, gets a little cleaner. And we can use the black point to clip the background. Looks like there might be a little reflection nebula, not too far. Another nice thing with Cartesiel, you can add in a bunch of catalog information. So you can include a little bit of information for the most common objects, including a little picture, which is nice when you're kind of surfing around for prospective or potential targets. So let's see if we can check out that little nebula.
Just comparing your 27 shot there to what I got last week. Feels like one of the stars is different brightness between ours. That's the difference.
Could be. Are you using a DSLR?
No, this was the EV scope.
Okay. So I would guess the EV scope is unfiltered? Because it's all reflective optics, it could be.
I guess that's the central star.
Yeah.
Straight up from that, there's kind of that column of stars.
Right here.
And the middle star would be left to right. Yeah, that star right there is much brighter by picture.
Hmm.
One that's between across the two bluish stars at first.
Yeah.
Just above.
We could check the B minus V and see if maybe one of them is more heavy into the red infrared. So that's 1.5, 2, 1.5. At least with mine, the two top stars, or these two stars, look like B minus V 1.5, and then this one is 2 point something. So it looks like my infrared filter is definitely cutting some of that, because they're magnitude 12 to 13. Oh, that one's 14. Oh yeah, it can be tricky. I think you can, it'd be similar to this, or it's kind of hard to see what's going on. I also have the Gaia data release 2 installed into Cartesiel, and it can get out of hand if you zoom in and turn on the stars. There's a couple buttons for really quick adjustment of what's visible. Oh, looks like it froze a little bit. Probably didn't like drawing a million stars.
too faint.
No. It's always, oh yeah, true. But previously I was using a setup very similar to the EV scope, an ASI or a IMX224 sensor and a 4.5-inch f4 or f4 Newtonian. That was a lot of fun for EAA. It's a really, really perfect pairing. The two kind of play to each other's strengths and weaknesses.
So I'm sharing, I think I'm sharing my picture just right now. You can,
In
there's
the
this stars
EAA?
here which are drastically different.
On the EAA text group.
It should be the it says I'm doing live in EAA voice channel.
Oh, okay, I see. Yeah, I can see your screen. Is it okay to drag this onto my live stream? Just to show people for comparison? Oop, I clicked the wrong thing. Just trying to see the orientation. So I think these two stars are those two.
Rotated like 10 degrees.
Yeah. Okay, so this chain of stars is this chain. Oh yeah, that one right there.
Yeah, there's the right one, right, it's right near the central star. There's something right next to where it's not Mars.
Yeah. I wonder if it's a lot of infrared that's being cut by the filter, or UV. Yeah. And I think in the BV, it was a much redder BV value. So as it shifts into the red, the infrared filter might be cutting more and more of the brightness and leaving just the reddest reds. I wonder if that's what's going on. Actually, I might have an old non-cut picture. Good check. Let's see. We'll give this a little stretch while it's been accumulating data the whole time. But I've been really enjoying the star colors, that it's sort of easier to tell the difference between sort of the yellow and reds and yellow and blues, yellow and whites. Just because I think previously the infrared was kind of flooding the blue and green filters. I think they start to, the Bayer filter, individual filters, the blue and green start to pass infrared photons after like 760 nanometers. So things get kind of weird when infrared is present. Okay, so this one should definitely be without the infrared cut, but it's a slightly different stretch, and it looks like it's upside down.
Yeah, that's a lot brighter anyway than this one.
Although I think this one is a little more aggressively stretched, so it's harder to tell. I could try to.
Now it's brighter than the two neighbors. Whereas in the current one, it's not. It's much deep, darker red.
Yeah, definitely. Be neat to have a filter wheel, just to compare, be able to swap and see. Or to have like the UHC loaded in it, so I could be wide open UVIR or UHC, and then maybe one of the crazy dual band or tri-band, but those are pretty pricey. But at least it doesn't seem to cut too much of the hydrogen alpha, which is nice. I'm probably
The reds still look pretty good.
yeah, I'm definitely losing some performance on faint galaxies and stuff, just because there's a decent chunk of infrared in those objects. All right, let's check out that nebula over here, NGC 6823. So it looks like a cluster. Maybe the nebulosity is associated with it. We'll see. We'll see if anything pops out in a live stack. So we'll clear out the dumbbell. Oh, maybe. I think I can see a dark bar. So this might be a fairly large hydrogen alpha. I think I can see like a dark bar right there. So this whole kind of diffuse region might have a very faint red glow to it.
Yeah, it looks like it might be something involved in the noise there.
Yeah, it'd be pretty tough to pull it out. So the computer out there, I think it has its own dedicated Wi-Fi, but it's also able to connect to my home internet, but it's a much weaker signal because it's using its internal tiny antenna at a distance. But I think it might still be fast enough. Another cool thing with Cartesiel is you can just download a deep sky survey picture for the area. So we could see if we had a hydrogen alpha filter, this is sort of what we'd be looking at. And we can just barely start to make out that long, slender trunk that's apparent right there. For kicks, I'll see what can be stretched out. It's going to look pretty ugly, but we might be able to detect it. There goes the satellite. Looks like a little bit of a reflection nebula right there. (6823), and I think the hydrogen alpha associated with it is SH268, I think, 2-68. So I'm going to sort of manually dither. I'm going to pause the stack, take the telescope control, and I'm just going to nudge it north for maybe a second. I'll resume, and we can switch over to look at the individual pictures just to make sure that everything settles out and the mount's not moving anymore. And then I'll resume, and what that will do is it's kind of a rudimentary manual dithering. So the even with the dark frame and the flat frame subtracted, there's still a little bit of fixed pattern noise in the camera. So if you stack the same region for the same without moving a whole lot, the sort of patterns in the noise kind of get baked in. But if you shift the scope, oh yeah. Oh yeah. Is there, when you're doing the lucky imaging, I assume it's lucky imaging, high frame rate, can you just kind of jog them out, or does that mess up the frame detection?
Especially in areas where I don't have it perfectly in the plane of focus. I have slops in my focuser, so it's one side is sharper focus than the other. And this side of the sun, which isn't quite as in focus, I tend to get more even during the sun. It doesn't really matter what happens at all at that point, because it all the variation ends up being from
just the yeah.
So I'll get nice extra detail in the sun in areas where it's precisely in focus. In areas where it's slightly out of focus, this exaggerates the sensor.
The grid. If you were to rotate, I know it'd be difficult to accomplish, but if you were to rotate the camera instead of translate, would that help? Averaging grids at different yeah. We can start to see that dark lane there too. Yeah, fix the root, not the symptom. Yeah. But yeah, it's usually always better to chase down the root cause instead of applying band-aids. Yeah, that would be so nice. That's one thing I want to try to get working or to do, just because after a temperature swing, I can notice some loss in sharpness with the focus drift. But it'd be nice. I think SharpCap, you can connect to ASCOM focuser, and it'll do a focusing routine. It'll hunt for best sharpness.
It's really hard with doing it in the sun as you're trying to.
Yeah, you're fighting the seeing.
The computer screen is washed out in the sun while I'm trying to
On top of everything.
It's one that came with the telescope is the helical focuser. You zoom way in on the computer to be able to see the detail. And whenever you tap the telescope, it shakes like crazy on the screen.
And then all the glare on top of it.
Yeah, so it's, I think moving the tronic focuser is the way to do that.
I always thought that a motorized focuser would be more trouble than it's worth, but then I got to use one at the club. Trying to remember, someone had it on their solar scope, and it was Paul's, and it was so nice. Just not touching the scope and not inducing any vibration really let you see when it was perfectly maximum. Which is nice. Oh, looks like there's two emission nebula next to each other. These can be hit or miss. A lot of times they can be, like the one we were just looking at, extremely faint. Really, you'd probably want to do monochrome with a hydrogen alpha filter, but the Bayer matrix can make do. It's a pretty interesting pattern. So let me get the names of these: SH2100 and SH299. So we'll start a live stack. Clear out those. Cygnus is always a really neat area to kind of hunt around. Tons and tons of dark nebula and tons of emission. The Milky Way is going right down the middle. So you can see there's definitely sort of some dark patches here and there. Dark nebula are pretty fun too. We'll see if we can get a preview of. They can be really hit or miss. But if there's at least in a good strong star field, sometimes they can be noticeable. I find the flat frame calibration is critical for being able to detect them, because if there's any vignetting or dust motes on the camera, it's kind of guesswork as to what's vignetting and what's the dark nebula. So it looks like there's some pretty high contrast bits. Like there's a pretty strong star field and a very, very dark black. So maybe we'll give this one a shot. So these are the two smaller hydrogen emission objects, SH99 and SH1 or SH2-99 and SH2-100. We're still in Cygnus, just kind of poking around. So we'll give this a shot. Let me get the name. B147. So not much jumping out, but usually, especially the very faint emission nebulas and the dark nebulas, the live stacking, or just stacking in general, really helps. And stretching the histogram to try and accentuate it. Looks like we've got a little bit right there and a little bit right there. You can just see kind of a distinct absence of stars.
Reminds me when I was first looking at the Sagittarius star cloud, realizing it was you could see through the dust, just staring straight down to the Milky Way, and that's just stars.
That's so cool. Really makes you feel like you're in plane of a galaxy. Just a soup, thick soup. Yeah. It's incredible that all that dust and gas is enough to nearly completely block the nucleus. Or maybe it's a good thing. Maybe the sun would never set. I always imagine the night sky you would have if we were not on plane, if we were slightly out of plane.
Like those groups of stars near the top center of their image, where there's tons of little stars that shine.
Oh yeah, look at that. We'll zoom in. It's like two chains. It's like a little smiley face. Has the two bright stars and the little smile. Nice. And then this one's a little crazy smiley face with a lopsided smile. Looks like maybe a little bit of red hydrogen alpha there. Just a little. We can crank it just to see. A little bit. Looks like I'm starting to get some kind of, the edges are glowing a little bit. That's probably, you know, a little mismatch on my dark frames and my flat frame, or just some inaccuracy in the calibration. I still have a little work to do on my flat frames. They're not ideal, but they're better than nothing. Yeah, it's like, I'm guessing the way I have it set up, the panel's pretty close to the opening, so the light isn't remotely collimated. It's just sort of diffuse crazy, and I guess a lot of times you get bounce off of the window of the camera, so you get, although that would make it darker. I don't know. It's voodoo. You gotta consult the soothsayers and see what they say. I know that the 294 is particularly sensitive in the way that the flat frames are calibrated. You can like include bias, but the bias response is very different from short frame to long frame, and it's just big long form threads on it. So they recommend taking little dark frames that match your flat frames, and when you take your flat frames, you dark correct them. They call them dark flats. I've been trying it, but I haven't noticed a ton of improvement. I still get the fixed pattern noise. So then for very critical objects, I'll just manually dither, and that takes care of most of the fixed pattern noise. It looks like the stars we were looking at earlier are part of NGC 6871, an open cluster, just at the top of the frame. Let's take a look at the veil. I'm going to try and frame sort of the lower section here where it fans out on the western veil. And then I think I can tell it to just point to the chart center. So instead of selecting an object, it'll try to match the preview that I have here. So the veil should be a lot brighter and more apparent than those dark nebula or the emissions that we were looking at. So let's start a 5 stack. You can see the veil there. The first exposure is always a little noisy, but it starts to average out, clean up. But we can see start to see two sort of detached sections of emission out there, and they were there on the star chart too. Yeah, it reminds me of old 3D movies with the colored lenses. It's incredible to be able to see the colors. It's so cool, and that they're so vibrant, albeit at very low levels, low brightnesses. And the saturation isn't cranked too much. You know, I could crank it, but it also boosts the noise, the chromatic noise. So I usually keep it somewhere manageable. We can check out Pickering's triangle or Christmas tree. You can clear the live stack and it should start accumulating frames, assuming the mount moves properly, which it's been pretty good about. So you can see a little outline of it there. It's a lot fainter than either the east veil or the west veil. I'm going to clear it. There's just a weird bug with the current SharpCap where you can't relabel a live stack. So it has to have the right name at the beginning. Didn't used to be that way. I find it's always kind of hard to color balance around Cygnus because there's so much hydrogen alpha. A lot of times the background seems too red, but it's actually just an extremely large diffuse field of hydrogen alpha. So a little wisp down there. I wonder if that's a reflection off a star. No, it's the tip of the west veil.
I guess that's the tip of the veil.
Yeah, I think so. Checking the wide field, we've got, you can see Cygnus and then Lyra. Still kind of hunting around the same area, but it'll show you the approximate location of the veil. Kind of go down this wing, and then I see this little triangle right here. I can auto hide these. I just find at least with the remote desktop, sometimes it gets a little glitchy when you re-expand. Sometimes the text gets murdered. Like you can see down here, it's pretty ugly.
Goes through the compression, gets to YouTube, and it's crazy.
Oh, joy. Check out this southern portion of the eastern veil where it kind of fans out. So we'll just assume that we're on target. We'll clear out the old live stack and the new one will start. Not sure if I've ever looked at that one. Looks pretty square. IC5068. We'll check it out. Some really nice stuff around Sadir too. Well, we could check maybe M33 has risen. Yeah, it should be clear. I'm going to take a quick look at this nebula before, and then we'll do a meridian flip over there. Yeah, you can see a little squiggle from the mount moving. So we'll clear out the live stack and we should start a new one. Although I should probably check if we're on target because that was a sort of medium length move. Looks like it. And this whole area is really chock full of hydrogen alpha, so it's hard to color balance sometimes. At least I usually go off of the sky color. So when the whole sky is red, it kind of throws me off. So let's do a meridian flip and check out M33. We'll issue a go to, and we'll watch the wide field. I recently switched to a little 5mm lens, which gives an even wider field of view. I found the mount is reliable enough for landing on target, and that the E-finder is really more useful for seeing clouds and trees. So having a wider field of view helps that. Looks like I can just make out Andromeda there too. Maybe. So let's clear this out, and we can check against. Let's see. So right now the finder scope is flipped because we've done a meridian flip. The view is rotated 180, so we can simulate that in the star chart. And then we go back to the finder. So we've got Andromeda down here. So it looks like we're a little off center. So I'm going to decrease the exposure, and we're just going to boost the short little frames. And then I'll take the control for the mount and just nudge it. It's always a guessing game which way to go, and that was the wrong guess. So we'll go the other way. Looks like it's decent, north-south. Looks a little hazier than normal, but we do have some high altitude smoke from the western fires. But the camera should be able to pull out some detail. So we'll start a live stack and start accumulating those 8-second frames. M33 is one of my favorites, especially with the scope and camera combination, because it just about fills the field of view, and you can zoom in and see tons of little nebula. I mean, well, massive nebula inside M33. You can only imagine how they appear in a night sky close to them. And a lot of these are big enough that they're cataloged as individual NGC numbers. So I'll have to flip the view here because we've done a meridian flip. But you can see, for example, this very bright one there is NGC 604. And it looks like this one is cataloged IC142. This one NGC 595. And then hard to tell whether it's this one or that one. I think this one is 588. I'm gonna manually dither. So I'll pause the live stack and I'll move north for maybe a second. I'll check the individual frames to make sure that it actually moved. I should probably move a little more than that. It's a little sluggish with the 8-second refresh. That should be enough. So we'll resume the live stack, and we'll see a dark bar start to appear because we're no longer capturing data. Yeah, up there. But when you dither, you want to move more than the fixed pattern noise pattern. So I've got kind of, you might be able to see these little dark granules and bright granules. They look like maybe 10 pixels about. So when I shift, I want to move by more than 10 pixels, preferably maybe 30 pixels or so, just to land on a different non-repeating pattern. And if we go to the drift graph here, it'll show us I've moved about 100 pixels, which should be more than enough. So as the new frames come in that are slightly translated, hopefully that very subtle modeling will start to blend out. Yeah, I really love the new camera. The 224 was extremely capable, and it would give very close and detailed views. But it's really fun to be able to kind of surf around and zoom in and out to different sections, and then get the big picture. But the EA, the live stacking, has really changed the game for me, to be able to see the structure so accurately and clearly, and the colors too, as a bonus. It's fun. At a cost, you know, it's more complicated, not immediate. You don't get the same connection that you do with an eyepiece though. You gotta remember not to pan around too much, because the YouTube compression wreaks havoc on it. Oh yeah, I watched a previous live stream where I was highlighting a lot of stuff. Like, oh, look at this nebula, and the mouse pointer's just obliterating it. So that one looks really green compared to the others. Sort of blue-green. I think I had looked it up, and it says all three of these are hydrogen alpha nebula. There we go again, pointing and wrecking it all. I thought that it might be oxygen 3 or something, just because it's so blue-green. But I imagine that would be an enormous oxygen 3 nebula. It's a little green. Let's check out M31's really close, or not too far. A lot of little stuff too. Gotta remember I flipped this. Sometimes I forget and it's just brain bending. Like, well, I could have swore I knew the constellations. They're all mirrored and backwards and flipped. We'll just go straight centered on it. Here's Andromeda. Looks like I'm going to center on it, and then I'm going to sync them out. Just because since the meridian flip, it seems like most of the targets are landing over there. Oh, gotta decrease the exposure just so it's a little easier to realize what's going on. It's close enough. So we'll turn off the crosshairs, relabel to M31. We'll bump up the exposures to 8 seconds, and we'll start a live stack. We'll clear out M33. You can definitely see some dust lanes. And we've got both M32 and M110. Oh yeah, I want to sync on M31 before I forget. This will just help the mount land more accurately on things in the area. So now the sort of representation of the camera more closely matches reality. Looks like we might have a, I don't know if it's just intense star forming region or maybe some nebula on the far side. Hard to tell. Andromeda is always spectacular. We could check out, what is it, NGC 185, and I forget the other number, but there's little satellite galaxies, or dwarf satellite galaxies of Andromeda. I think they're close to Pegasus, or in Pegasus, or on the border. Maybe it's halfway to Cassiopeia.
Detail and said Andromeda, even though it's much bigger and brighter than the last one. Because it's more edge on than face on like the last one.
It's kind of, the brightness and contrast is kind of stacked up. Let's see if we can land right between these two and get them both in frame. I'm gonna save this one before I go. I might stretch it just a little more, although you start to blow out the center. I think with some of the more advanced post-processing tools, there's a way to do like non-linear stretches and masking areas, and you can kind of get it all. But for the simple stretch, it's good enough. Yeah. Especially in like M13 globular clusters, because there's such a massive difference in brightness of the sort of very outer faintest members and the super bright stars all stacked on top of each other in the middle. But the core of Andromeda is crazy bright too. It looks like we have both in frame. I'm gonna get the names. 147 and 185. Here. So we're already at 8 seconds, and we'll start stacking these. These ones aren't as spectacular, but they're still pretty neat. One of them has like a little dark patch close to the center. The other one is much fainter and more diffuse. I wish I had this set up when these two objects were in the Observer's Challenge. I think I was able to look at them with the 224 individually, sort of zoomed in on each one, which is nice. We can just start to see it's like a little dark splotch right there. It looks like I might have some flat frame issues. If I stretch a lot, I can see the border is a lot brighter than the center. So I might be overcorrecting a little bit. Or an issue with the way I captured it. We could check out Pelican Nebula, although it might, we'll see if it's clear, although we should be able to see it in the finder scope. It should be clear. Looks like we can see all of Cassiopeia right there. That little M. And we can just see the double cluster right there. We'll take a look at that. That one's pretty. Actually, let's check out Caroline's rose, and then we'll sort of work our way down Cassiopeia. We'll take one last look at this guy. You can really start to see that little dark spot. I know our audio is pretty close to instantaneous, but your video, my video coming through YouTube is probably, yeah, 8 seconds. This must be weird trying to parse what I'm pointing out. Gotta wait for it. I imagine if you didn't mute the video, it'd be hell with a weird echo. Yeah. We'll issue a go-to. Seven, 7, 8. This is a really nice cluster visually. Oh, that's, we could check out the bubble too. Usually I end up framing the bubble nebula with M52, but I think I'll try to frame it with this SH2-158. So I'll clear out the stack and it looks okay. Yeah, the view is flipped. I might nudge it a little bit just to get the bubble away from the edge. So I think I want to move west. Wrong. Go back to 8-second exposures and we'll start a live stack. Oh, I think I'm stretching it twice. There we go. Now let's check out Pac-Man. Let's clear the live stack and see if we landed on it. A little high. So I'm going to exit the live stack and use the telescope control to try and center it up a little bit. Wrong way. Yeah, I probably overshot it a little bit. It should be good enough though. We'll reset the live stack on it. And I'm gonna sync the mount to it. That should help us point more accurately in this area. So you can definitely see the likeness. Right now it's upside down. It's very circular nebula with a wedge taken out of it. It's even got an eye. If we look close, we can start to see a Bach globule, just a completely detached clump of gas and dust silhouetted against the hydrogen alpha, and very likely host to protostars forming, which is really cool. Some really cool images of infrared telescopes that can peer through the gas and dust and see the protostars coming together in there. Yeah, it'll be really cool when James Webb is up and running. When if. Hope it goes well. No repair trip on that one. There's another really cool type of object called the Herbig-Haro object, which is a protostar that forms in a cloud like that. I guess some of them eject material out of the axis of rotation of the accretion disk. So you get these high velocity jets, and they blast through the gas and dust, and you get these sort of compression shock waves as those jets collide with the gas surrounding them in the emission nebula. And there's one in the Pelican, which I've always tried to see, but I've tried it maybe 3 or 4 times and I haven't quite got it. But it's on the bucket list of things to observe. Just to see like the direct evidence of stellar formation would be so cool. I've seen people get it in smaller apertures, but using narrowband and mono cameras, so they've got a significant resolution bonus and contrast. But we could point to the area where it is. Or not. Oh, well, yeah, we are. We're on the other side of the meridian. So it's close to the North American Nebula. So if I zoom way out here, let's see. So here we are in Cassiopeia, and this white line is the meridian. So if we go back to Deneb, where we were at the beginning of the stream, near Cygnus, there's the North American Nebula. And next to the North American Nebula is the Pelican Nebula. And if you look sort of beyond its eye at the back of its head, there's a little dark trunk. And I'll see if I can get a DSS image to show it. That'd be pretty cool. But right at the tip of that trunk, there's this little perpendicular white streak, and that's the Herbig-Haro object, that the sort of axial jets flying out of a forming protostar. It's really cool. So this is an image from a professional astronomy sky survey, but you can just barely see at the end of that there's a perpendicular structure. Maybe I'll zoom in a little more. Enhance. I'll turn off the star charts stars. But I've been trying to get that for like a year and a half, no luck. I've sort of kind of threshold detected it, but I haven't quite resolved it. But these 2 stars there are a pretty good gauge. So if you kind of go to the end of the trunk, and there should be a bridge of light that sort of runs down to those 2 stars. That's a fun one. Let's check out the double cluster. And this probably won't, yeah, I'll have to, we'll see how it looks. We'll exit the live stack, we'll go down to 2 seconds. So I'll just adjust it until it's centered. I think I targeted just this one. I like how when the mount moves, the star color becomes a lot more apparent, just because it's kind of spreading it out and it's not so overblown. It'd be nice to have a motorized focuser so I could purposely defocus just to really, really accentuate the brighter star colors. Yeah, I'll leave it at 4 seconds. We'll probably end up blowing out some of these bright stars. So I've got the correct dark frame, and I'm not sure if I saved this one, so I'll save it. Now we'll clear it. And I'll clear it again just so that the name applies. It's a weird thing with SharpCap. You can definitely see some of these brighter red stars kind of sprinkled on top. This one's a really great object for outreach. There's another really fun cluster nearby called the OWL or ET cluster. The cameras don't do it justice, but in the eyepiece it really looks like a little stick guy, little stick man with 2 eyes and outstretched arms. Or I guess some people call it the Wall-E cluster now. Let's see if we can go for it. I think my field of view is a little tight. I might clip off the edges of its arms. But it's locked on. There we go. Here it is here. I usually think of it, here's Cassiopeia. If you were to fill in this area with a right triangle, that would get you pretty close to where it is. No, it's pretty well framed. So there it is. And for once, he's actually right way up. So you can see the two bright eyes, and then kind of a torso, some feet or tail feathers, and then some arms or wings. It's a fun one. I think if we go to 8 seconds, we'll probably pull too many stars and it'll be hard to see the shape. It kind of gets lost. And the Cassiopeia is absolutely chock full of open clusters. A lot of really nice ones. I think M103 in particular I like. It's got a nice sort of red-orange star right in the middle of it. You could just hop around and take a look at all the clusters. Just go from one to another. And the clusters are usually bright enough that they do well without live stacking. That's a nice one. This one has lots of pairs. This is NGC 654. I think I remember looking at this one in the 17-inch at the club with Rich. In the eyepiece, you could notice the pairs. It's funny. And I think if I decrease the exposure time, it might be closer to the visual look. Most of the faint, or sort of most of the threshold stars seem to occur in pairs, which is kind of funny. And while we're at 2 seconds, we can apply the correct dark frame for it, and that should get rid of some of the hot pixels. And I've looked at this one before, IC166, and it's different. It almost looks like a globular. It's very, very, very faint, very yellow stars. They're all pretty old. And let me increase the exposure. We'll go to 8 seconds for this one. And it turns out this was also discovered by Clyde Tombaugh in a photographic survey. And he had his own catalog of Tombak clusters, and they're all pretty similar to this one in appearance, where they're very, very kind of yellow stars, very faint. And if we live stack it, it should be a little more apparent. And the first time I came across a Tombak cluster was in the Heart Nebula. There's one in there, sort of between the open cluster in the center of the Heart and the brighter Fishhead Nebula down at the point of the Heart. Kind of halfway between, there's another one of these very loose, very faint, very yellow clusters. You could see why it was only discovered photographically compared to those other open clusters. It's very faint. Yeah. That's what I thought it was at first when I saw the one in the Heart. But it took me a while to figure out what it was, because the one in the Heart doesn't have a catalog number, at least in Cart to Seal. It doesn't have the Tombak clusters. And the real sort of twist is, in most photography, it doesn't show up at all because everyone's doing narrowband of the Heart. And in narrowband, it just disappears because it's so dim to begin with. So in almost all the reference photos, there's no cluster there. But in my photo, there was a cluster. I was like, what the heck is this? And it's not on my catalog. But then I found a picture with it in there, and it had a description. And then I read the Wikipedia on the Tombaugh photographic survey, which is cool. And we could check out the Heart and see if we can find. I think this is Tombak 4, and then the one in the Heart is Tombak 3, and this is the only one in his catalog that he accidentally rediscovered. It was previously discovered as IC166. But if we look here, so the cluster, I think, would be, so there's kind of the cluster in the center of the Heart, and then this would be the fish head. It's kind of halfway in between, and there's no marker, but if I keep zooming in, the Gaia star data starts to populate, and you can see there's definitely a sort of very orange red star cluster right there. So we'll slew them out over and see. So let's clear the live stack. and how it should accumulate. I'm not sure if the mount has settled. It looked like it settled in. And this view is 180 degrees rotated, just because we've done a meridian flip. So there's the fish head, aptly named. And now we can just start to see that Tombak cluster right there. And then this is the open cluster that's in the center of the heart. And it was really strange because I saw it and I was looking for reference photos, and it was just really weird not to see it in the reference photos, because I'm assuming it's because most of them are narrowband and they just fall off because they're so dim to begin with. Pretty great cluster of galaxies in Perseus, but I don't know if it'll be in a tree or not. Looks like it might just be coming out of a tree. Let's give it a shot. Yeah. My horizon map is approximate. Maybe M34. Not sure if I've seen that before. But NGC 891 is also very cool. It looks like a nice open cluster. A lot of chains of stars. I'll go to 8 seconds and I'll make sure to use the right dark frame. So this is a nice edge-on spiral galaxy. So we're right in plane with it. So it's kind of similar to our view of our Milky Way, where all the obscuring gas and dust stacks up. So it looks like we might also have some smaller, fainter galaxies in this field of view. To the upper, upper right. We've got 1, 2, 3, 4, 5, 6, 7, 8. Oh, another one there. Thanks for tuning in. It's always fun having people to talk to on the Discord. Thanks. Yeah. Have a good one. Looks like a couple chains of stars there too. That one looks like it could be nice. NGC 925. Gonna save a snapshot of 891, and we'll go to 925. And we'll see what shows up. Come to think of it, we should probably be kind of staying close to zenith within any of the smoke and haze. There are a lot of great teeny tiny galaxies in Pegasus. That one looks pretty nice. Get the number 7741. I can start live stacking. Actually, I gotta bring it back to 8 seconds. And we'll clear out that one. Hopefully this will be a little cleaner, closer to zenith. You can already see how far the histogram shifted toward black. Just because we're a lot closer to zenith and the sky is a lot darker. Be looking through less ash and less air and light pollution. Ooh, that one looks pretty cool. So tonight I'm just using a UV IR filter, and I feel like it helps to give more natural star colors, but it does lose a little bit of sensitivity on these faint distant galaxies, just because there's a significant portion of the light is in the infrared. Be nice if I had a filter wheel where I could change out, switch between a UHC, or UVIR and wide open. But tonight I'm using a UVIR. Well, you can see a little bit of that structure. Looks like a barred spiral, where one arm comes down here and the other arm goes up there. Looks like I could definitely use a focus tune-up. Can start to see little donuts, so I might go do that. So I'm gonna find a decently bright star overhead. Go here. And it'll probably take me 5 minutes or so to go down there and tweak the focus. I don't have a motorized focuser. So, but I can save some time by centering the star remotely. Alright, so while I'm here, I'll think on it. And I will open up SharpCap's Focus Assistant, Batten-Off mask. And now I'm gonna walk down there and manually do this with a laptop. So in the meantime, I'll use OBS to put on a little focusing screen. I'll be right back, maybe 5 minutes. back, so we'll see how that goes. It was definitely way off. One of the next things I want to try and make is a motorized focuser. The Onstep'ed project has the capacity for it. Just gotta add the wiring for it. So hopefully with that set we'll get a lot more detail on these teeny tiny little galaxies. I think one of these looked pretty interesting. Yeah, that one. So let's go for that one and see how it looks. I'll bump it up to, wrong way. I'll bump it up to 8 seconds. Make sure my dark frames are for 8 seconds. And let me get the catalog, NGC 90. 90, and we'll start a live stack. I never checked to see if it was centered or not. That looks like it is. It's like a group of 6 or 7 galaxies. Stars are looking a lot better, less like a donut. There's a lot of galaxies. We can look closer with Cartesian. So I think on this side of the meridian, the camera is upside down relative to the chart, so we can temporarily flip the chart just so it makes a little more sense. So I think this one here is NGC 90. And we saw the little preview in Carte du Ciel where it has pretty well defined little spiral arms, almost hook shaped. There's really a lot of galaxies there. A lot of these ones are pretty teeny and tiny, but they're all entire galaxies. Just nuts. And they should show up in, yeah. You can install a extended catalog into Carte du Ciel, and the number of galaxies that show up are just insane. So it looks like this one is NGC 85. NGC 83 and NGC 80 up there. I wonder if this is a Higgston compact group or not. We're starting to see more resolution on those arms, or they're starting to emerge from the noise. Looks like a couple more up there too. That one looks pretty good. NGC 7771. So we can clear the live stack and see if we landed on target. Looks like the mount wasn't quite finished settling down. So I'll clear it again. I wonder if that's a separate galaxy. Yeah. So that little one there is 7770, and this is 7771. And this one looks like it might have some interesting structure. I don't know if I'll be able to get that faint on it. Looks like it has some very faint, distant arms kind of flung out. That'd be 7796. I wonder if Mars is out of the trees. Nope, not yet. So recently I went through the trouble of creating a horizon map for Cartesiel, which has been really nice. Saves me the trouble of slewing over and checking the wide field. Although it looks like Mars is just starting to peek out of the trees there. the camera views are flipped compared to the star chart just because I'm on the other side of the meridian. That one looks nice. Looks like a little miniature M51. Let's check it out. What's the number? 7753. Oh, the black point a little too far. Pretty faint. Oh wow. It's a really, really thin edge on. It looks like it's reasonably sized too. Looks like we're just starting to get that faint arm that's reaching out to that smaller galaxy. I don't know what the number would be, but I bet this is an ARP galaxy. I'm going to do a little manual dithering. So pause the stack. Nudge the scope for 1 or 2 seconds. I'll let the mount settle down. Now we can resume the stack. And if we check the drift graph, we should see a pretty large jump. Yeah, 150 pixels shift. For the teeny tiny galaxy, it doesn't really matter. We'll lose a little bit of the sort of edge of the view, but it should help to start to break up that little bit of fixed pattern noise kind of modeling that I have. On really, really dim objects like this, usually the fixed pattern noise becomes the limiting factor. Because no matter how long you stack, the pattern just kind of gets ingrained in it. But if you can shift the view around, then that non-repeating pattern eventually averages out. And I'll dither again. So I'll pause. This time I'll move west. Check to make sure the mount settles down. Looks like it will. I'll just resume. And now we'll start to get a black bar, yeah, on that side. And we can see in the drift graph that we're now almost maybe 100 pixels to the side. Hard to tell if that's a very faint threshold star or if it's a star forming region in the galaxy. I bet larger scope and more time would resolve a lot of nice detail in that. I'm going to go for that really thin edge-on spiral. It looks like we're centered on it. So that is 7814. Oh, I forgot to save this one. Has a little star going through it, but that's okay. I'll clear it. Can just barely make out that thin dust line going right through. Should clean up as the noise decreases. That looks pretty tough. Probably a very low surface brightness, IC1613. But this thing's cleaning up nice. A nice kind of reddish brown dust lane. I'm thinking this one's going to be in the tree probably, but we'll see. Just barely. But Mars is out. Weird. I'll be right back. That was a little weird. Booted me from the remote desktop for a little bit. So let's slew over to Mars. So I don't have the scope's not really set up for planetary. It's a f4 8-inch Newtonian, so the sampling's not ideal, but we can try. So it's pretty bright. But pretty short exposures. I'll center it up and then I'll do a region of interest. Try and get really short exposures rolling pretty fast. Yeah, close enough. It's going to complain about the dark frame and flat frame not matching. So now we can take this way down. Here's half a millisecond. And I can see a dark patch. And you can clearly see the pixels at this pixel scale. Ideally, I'd put a 5x Barlow in there, and that would get me to f20, which would be closer to ideal for the 4.63 micron pixels. But you can definitely see a little hint of an ice cap, and then a dark region right there. Very nice. I don't think it'll be any good, but we could try to do a basic live stack for kicks. So I've turned off alignment, and I'm going to clear, and we'll collect a couple frames, and then I'll pause it. So now we're no longer accepting frames. But it looks like it kind of overblew. Oh well. You can definitely see a little bit of an ice cap. It's only like 2 pixels and only there occasionally, but there's a white to sort of bluish spot right about there. Might actually look better with less zoom, at least to see that bright spot over there. It's really dancing around. Let's check out M74. Not sure if I'll get any sort of gradient or internal reflection. I don't have a shroud on the newt, so it might catch some light from Mars. So I think I might wrap it up pretty soon. Any last requests in chat? This is my horizon. Well, I think I'm going to wrap it up. Thank you to everyone who tuned in. Have a good night and clear skies.